Now we're all ready to jump into our first calculus topic. The wonderful part about this course is we are only talking about 3 things the entire semester: limits, derivatives, and antiderivatives. So it's much less overwhelming than an algebra class. So first of our 3 topics for the entire semester is limits. So we're going to learn them graphically, so from a picture, and algebraically, which means from an equation. So, when studying a function y equals f of x, we find ourselves interested in f's behavior near an x value, not just at an x value. So I know it's harder to read on my paper than it is yours. But we want to talk about being near an x value. We're not just plugging in x is 2, because sometimes we can't plug it in, right? It makes us divide by 0, or we take the square root of a negative sometimes. So if we can't plug in 2, because say it makes us divide by 0, we could still plug in 1.9 and get an idea of where we're at. Or we could plug in 2.1, something slightly smaller or slightly bigger than 2, and then see if we plug in 1.9 and our y value is 6, and we plug in 2.1 and our y value is 6, then probably if we could plug in 2 without dividing by 0, we would be near 6. So instead of just saying, hey, we can't plug it in, we're going to plug in a number near it, something to the left or to the right. So that's the whole idea. I remember when I learned limits, I was so confused because I just thought it could not be this easy. If you can't plug in 2, plug in 1.9 or plug in 2.1. Kind of a weird concept, but that's what we're going to do. So the notation for this is also a bit crazy. To say that the limit, let's get used to writing these, limit is just LIM as x goes to c. So in my example that I just said, as x goes to 2. So as x gets near 2, either from the left at 1.9 or from the right at 2.1, we would write LIM for limit as x goes to c, some x value, in the function f of x equals L. Let's break down what this means. Lim as x goes to c of f of x equals L. What does that mean? This means that when x is near but different from c, or in our case what I was talking about was 2, f of x is near L. Remember, f of x is just a function notation for a y value. Is near L would be the other way of saying it, out of function notation. The y value is near L. So all we're doing is we're saying x is getting close to 2. What's y value getting close to? So I said as we get close to 2 on both sides, we got close to 6. So 6 would be our limit. We're literally reading a graph and getting near an x value and saying what the y value would be. So L is called the limit of the function. And what it really is just the y value. L is the y value that the function approaches as x value approaches c. So all we're doing is reading how high or how low are we on a graph. So with this, we get a limit does not exist. And this is in like some movies. If you've seen Mean Girls, this is like one of the big answers is the limit does not exist. So it sounds like it's going to be something fancy, and they do use it in movies for some reason. But a limit does not exist simply if the function approaches a different y value from the left in comparison to the right. Let's write this out in math notation in a minute. But basically, if we from the left, if we plugged in 1.9 and we got 7, and then for at 2.1 we approached on the right, and we plug in and we get 10, 7 and 10 are not the same numbers, so the two-sided limit would not exist. So from the left and the right, you have to get to the same number. So with this, we get a one-sided limit. And just to hit on this, the answer is never D and E. It never cannot exist. If you come in from one side, then you have a limit. The only time it does not exist is if you're coming in from both sides and the left y value is not the same as the right y value. So a one-sided limit always has to exist. It can never be D and E. It does not exist. So if f fails to have a two-sided limit at c, it may still have a one-sided limit. So let's get these notations for each side of a limit. Again, crazy notation, and then when we do it, it won't be so bad. The function f of x has the left hand limit, which I'll usually never write out. I'm just going to call it the LHL, left hand limit, as L as x approaches c is written, we would say lim still, as x approaches c, of f of x. But to denote that it's just the left-hand limit, let's think about number lines from back in elementary school. If you were coming in on the left side of the number line, is that the negative side of the number line or the positive side of the number line? It's the negative. So to denote a left-hand limit, you have a negative after the number. So instead of being in front, which would say like -1 would be -1, it would be 1 from the negative. The negative would be after. Equals L. That's how we would write that. The left-hand limit as x approaches c from the negative side of f of x equals L. There's a left-hand limit, how we would write it in math notation. If we compare that to a right-hand limit, the function f of x has the right-hand limit, which I would normally just write as R, H, L, M. And I'm not using the same letter because they're not necessarily the same number, right? This could be 7 and this could be 10, and then the two-sided limit would be D and E because they're not the same. So they don't have to be the same number, but they could be. And then the two-sided limit would exist. So it has the right-hand limit M as x approaches c. This is written the limit as x approaches c, and because we're coming from the right side, that's the positive side of the number line. So you have a positive after the c of f of x could equal m. So this is probably super confusing and overwhelming, and that is totally okay. It's going to get better once we look at a picture. So writing this back in math notation, a two-sided limit does not exist if you get a different y value from the left in comparison to the right. Let's use this new notation and write that sentence in math terms. So the limit as x approaches c of f of x, that's a two-sided limit because there's not a plus or a minus after c, that equals d and e. It does not exist if the left and the right-hand limit are not the same number. So how we write that in math notation, we would say the limit as x approaches c from the left, so from the negative side, of f of x is not equal to the limit as x approaches c from the positive side, from the right. Okay, so our super fancy thing from the movies, if you want to say that the two-sided limit does not exist, that is going to happen if you approach from the left and you get a number like 7, and then you approach from the right side of the graph and you get 10. So if we plug in 1.9 and we get 7, and we plug in 2.1 and we get 10, that limit as x approaches 2 is not going to exist. We choose a number to the left and to the right, we don't get the same y value. Or graphically when our fingers don't meet. So super confusing, crazy notation for something very simple. So just bear with me and we'll look at some graphs.